Hey guys, and welcome back to my channel. So today I want to make a video on recursion. So let's get started. So recursion is nothing but a programming technique where a function calls itself to solve a smaller instance of a complex problem, breaking it down until a base case is reached. So this is our first problem in recursion. Printing 1 to n numbers. Over here we have n as 5, so it's simply printing from 1 to 5. So 1, 2, 3, 4, 5. Now in this case, you can notice that, for example, over here we got starting from 1, 2, 3, 4, 5. And basically, if I say you shouldn't use a function to solve this, we're probably using a for loop. Okay, so I'm just going to zoom in so you guys can see it. So we're going to be using a for loop. Over here you can see for int I is equal to 1 and go till I less than n and I plus plus, and we would just print. So we'll just print the I. So this is how you would solve it in a normal for loop. But we want to do it something just by using functions and calling the functions repeatedly until the problem of printing is solved. So I'm going to show you guys how to write this as a function. So first, we're going to have something called a function. Let's have a function. So I'm just going to write all of this in pseudocode. So let's have the number passed in inside of a function. Now this function takes in a number. This number is the ending number of printing. In this case, that number is going to be 5. So now let's start with our printing. Now before printing, we need to know what is the base case. And you can see over here that we're starting from 1, 2, 3, 4, 5. So probably the base case would be obviously 0, right? So once you reached 0, you no longer have to print any kind of numbers. You can also do this the reversal way and not non-reversal way. We'll look onto this once we do it. But for now, let's just have a look. So for this, the base condition is 0. So once the function call reaches 0, it obviously stops. And so this is the base condition. You want it to stop when it reaches 0. So this is what you want to do. Now we want to print all of these numbers, right? Now let's say I want to solve this as subproblems. Now what is the actual problem here? The problem is to print these numbers. So we do need a print over here, and we'll have a look at those. So yeah. So first, I would obviously write the base condition because we want to. If you don't write the base condition, then this is going to go take place very, very repeatedly. Okay. So before jumping onto this, I want to be very clear with you guys that what is recursion and how the functions look like. So for example, let's have a function a. Okay, let's name it capital A, and this is our function. Okay. So right now, I'm going to call the same function inside of this function. Now that is what we call as recursion. Now this is what I call recursion. I'm calling the same function inside of that function. Now this is what is called recursion. Now this doesn't really execute anything. So, and also it just keeps calling itself. For example, A calls A again calls this, and again it calls this. So it goes on like an infinite loop. Right? So that's what we say that we need a base condition for it to stop at a particular condition. Now we call that as a base condition because that is like an if. Like we need to obviously give it inside an if block to make it stop the loop continuously. So it's like really, I would say that it's a loop that is inside a function. So basically, you have to use it whenever you want to like repeat your task again and again. And also, it's like the same task you want to repeat it again and again, but for maybe a different numbers or different type of maybe. So there's a lot of varieties in recursion. So if you just dive deep into it, you'll come to know what are the types of it. So you can like further expand your recursion from normal recursion where it just prints the numbers to something that can solve very complex problems. Now in this problem, we don't really do anything. So let's write another program and let's make it do something. For example, let's have a function a. Okay, now let's have it to print something, right? And let's say hi. Okay. So right now, we're making this function print hi, right? Now this function prints something called as hi, and obviously it's going to have something like hi. Now, what do I say is, can it actually print this hi like 5 times? We want it to print like 5 times. The first thing comes off for using a loop, but I tell you, no, just call the function again. So you go like, okay, that's easy. So let me just call the function again. So like after printing hi, I'm gonna call this function again. And it's gonna say again, yeah, sure, I'll just go and print it. So again, it goes and prints this hi, and again goes inside and prints this hi, and again and again and again. But at one point, you would notice that it's printing it continuously, like hi, and then again hi, and then again hi, and then hi, so on. Like it's just crowding up. So let me first show you how it's going to like execute. I'm gonna like have this go on top so I can show you really clear. Now the first line of this code will be executed, making sure that it prints hi. Alright. So once it prints the hi, next it's going to call this function, and inside of this function it's going to have println. Okay, so it goes and calls this function again. So let's have this copied and pasted. Now this calls the function again and it executes the first line hi, and then it again calls the same function. So it goes and says again, and there we go. We call the function again and it prints again. So this continues literally like an infinite loop, right? But why? Because we didn't give a stopping condition. We didn't say, hey, stop at this point. Okay, we have reached a couple of times over here. Now, one way that you can actually do this is have like so one way you can use this is have like a count variable, and this variable can tell you, okay, this many times the function has been called. So right now it's time to stop because your count has reached a certain limit. And you can also pass them as a parameter. Okay. But what I would highly recommend when you're doing recursion is not to initialize the value inside the function whenever you're doing recursion. Like for example, let's say we got a, let's take the same function, and what we mostly people try to do is they try to like initialize the count equal to 0, and they give a stopping condition of, let's say, count is equal to 5. I want you to return back. I don't want you to do anything else. And then in the else condition, they would be like, hey, go ahead and print the hi, and then you can just call your function a again. Okay. So now this is what I'm sorry about this one. So this is what people would like mostly do, and I would say this is wrong because it just keeps updating the count value to 0 whenever you make a call over here. All right, when you call here A, it just says, hey, count is 0, and then it says if count is equal to 5 return, and then it would print high. It would print high in the first call, then it would call it again, and this also becomes an infinite loop. Right? It will just print high over here, and then it comes inside and calls again and calls, and it actually never updates the count, nor let's say we update the count. Let's have it like it really does update the count. But you should also notice another error over here. Let me show you. So you got over here the count is 0, right? So I'm trying to update the count. So let me update the count before I even call this. Okay, so yeah, so I'm over here. I'm updating the count, and I'm calling this function over here a, and it goes up, and it again sees the count is 0. Okay, because we initialize it every single time. So to avoid this, well, one thing we can do is pass this as a parameter of this function, or you can also declare it as a global variable outside of this function. So when you declare it outside, the value wouldn't change over inside whenever you're calling the function again and again, because it doesn't belong to the function anymore. All right, so the count is 0, and right now I'm gonna remove this line so that we can make it much more simpler. All right, so this is our first recursion program that we wrote. I know this is not the first program that you shouldn't be writing for a beginner. But yeah, this is also a great example, I would say, because you got a condition, you got a global variable, and also the possibilities of passing this as a parameter. Yeah. So the first count is 5 if you return, but my count is just 0. So if you just go ahead and print the high, and then make the count to be 1, and then call the function. Now when I go inside the function, I check if my count is 5, and then I return, but it's not 5, so I'm going to print high again. So this is my first high, and this is my second high. So during my first high, my count would be 1, and during my second one, it would be 2. And now I would just go ahead and call the function again, and still it would have my third high printing out, and 3. Now I'll just go ahead and do a fourth one, high, and a 4, and then high, and a 5. Now if you just yeah, so your count is actually 5. You return now high and then 1, and the count is 1, and then you do check. You call the function again, you check it, you don't return because it's not 5, and then you print high, and then the count is 2, and then you call the function again, print high, count is 3, call the function again, and then print high, and then count is 4, and you call the function again, you print high, and the count is 5. Now in this case, you can see that once you call it again, now this time when you call this function again, you go inside and the count is 5, you're going to return it. Okay, so you're going to return it. That means you're going to return it back to where it was called, and each time it just exits the function. So it might be a bit confusing. Let me just explain it a bit clearer. All right, so have a look at it here. Now this is our first one. Now this is our first time we're entering into the function. And in the main function, you said, hey, I'm calling this function. So right now you enter into this function. Your first condition is to check if count is equal to 5. It's not. So you print your high over here. Okay. you print your high. You have done your first job, printing the high. Now your second job is to increment the count to 1. From 0, you incremented your count to 1. So I'm writing C, representing the count variable. Now that you have done this line, we are completed 1, 2, this line is completed. We didn't enter into the if condition because it didn't satisfy. We have printed high, we have incremented the count, we've done the job. Now it's time to go for this one, calling the next function. Okay. Now you also need to remember that we didn't exit the function still now. We didn't exit, we just executed the next line, calling this function again. We go inside, do this job, checking the count. It doesn't enter into it, it just prints high. And then the count plus plus. So your count is now 2. And we're calling the function again. Now we didn't exit the loop still. Okay. Now we'll go ahead and check 5, and then we go ahead and print high. And then we just go ahead and count increase to 3 and call this function again. Now remember, we didn't still exit the entire function code, which is still inside the function. We just made a call for the next one. We enter into this function, the fourth call. We check the count is 5, no, then we print high. And then we increment it to 4. Now I call it again. We check it, no. And then we increment it once more. Sorry, we print we say high and then print 5, and then we call this again. Now I'll make this really quick. Alright, so I made a call once again, and then you see over here the count is 5, and I'm returning it. Okay. Yeah, now we return, and we're gonna return back over here and finish off this line where we left off. And it just returns back to where it was before. So it was before here. The call was made here, right? So it comes back and moves to the next line where the call was made. And it comes back here and move to the next line where the call was made. So this is the next line they exit. And then it goes back where the call for this one was made and moves to the next line of that one and over, and then it just goes back to where the call was made and moves to the next line to the code, and then it moves to the main function where the call was made and then moves to the next line of it, which is obviously this one or whatever the next line it was. It will just execute and exit the code. Coming back to the question that we discussed at the start of this video is to print the first 5 numbers. And I think that you have an idea. The first thing that we're going to write is the base case. And I'm going to say return. And now we're going to start writing off the code, the subproblem that we need to solve in this. The problem that we need to solve is to print each number of the functions. So we just go ahead and print that out. Print that one, and then just go ahead and print whatever the number is. And then call the function, right? So this is what you would be thinking. Let's have a function named as A. Just watch what happens over here. And yeah. So this was the last code that we returned, but let me just show you guys what will be the difference between writing your function after the print and before the print. So there are 2 major differences over here. Let's take a look. Will it print the exact result that we want, 1 to 5, or something different? So what happens over here is, so we pass in the number 5, Now, the problem is just immediately goes ahead and prints 5 and then makes a call for the function, right? And also you need to pass in the value again as n minus 1, which I would be doing over here. So here, n minus 1. So please do that. If you don't do that, then it's a wrong syntax. So that's why. So it prints a function 5, and we don't want that. We need to start it from 1, go for 2, then 3, then 4, then 5. In this one, if you notice the so if you notice the behavior of the recursion calls, it would behave like a stack, right? So it will like first in, like last in, first out. Let me show you. So at first we will do this call, which is A05, right? And this is the first call. The second call would be A04, and let's say we print 4, and then we would call A03. Make sure you store it in stack because you didn't finish the function calls. A03, and then it will just go ahead and print that 3. So print 3 and call A02. So go ahead and write that out. So over here we have A02. And then call A01. So right here we would call A1. And then we just go ahead and write that out. A1. Next, I'm just going to go ahead and start printing it. So we already printed it, so 2 and 1. Now it just pops up one by one, exiting out the call until it reaches the last one, where you call it the main. The main also pops out, and your stack becomes empty, and your function ends as well. So this as well pops up. So, but we don't want this behavior, right? We don't want 5, 4, 3, 2, 1. So what do you expect? I expect this behavior: 1, 2, 3, 4, and 5. So what we must do to achieve this, what we can do is try printing it after the recursion call. So it just prints it and then pops out. So over here, what it does is prints it, calls the function, and just leaves the program. But what if you could do like call all of this function and then start like popping out like after you print it and then pop it, print it, pop it. So I hope you understand what I'm talking about. So when we do this thing, when we print the number, when we first print the number and then make a call for the function, what happens over here is we print the number and then make a call for the next functions. So here we have 5. So we print the number a of 5. So we print the number and then make a call. So 5 is printed, and then it makes a call for 4. And then 4 is printed, and then we make a call for 3. And 3 is printed, and we make a call for 2, and then 1, and then it's 0 starts to come back. Return back to 1, 2. Pop it out, start popping out 1, 2, 3, because these function calls are getting finished up. What I would recommend is instead of popping it out without doing anything, we pop out after it prints that number, right? That would be much better. So sorry about that. Yeah, this is the function. All right. So instead of printing it, just make a call and then print the number. So yeah, so these are the two basics we saw. So whether to add a recursion before, we saw one case of after printing statement and before. Hope you guys like this video. Subscribe for more.